Section 10.5 is about other angle relationships in circles. Let's start with a theorem. So here's theorem 1011. If a tangent and a chord intersect at a point on the circle, so that's what's happening right here, then the measure of each angle formed is half the measure of its intercepted arc. So angle 1 would be half of whatever this red arc would be, and angle 2 would be half of whatever this arc would be. So let's put that theorem to use. Here's example number 1. Line M is tangent to the circle. Find x or y. So looking at our first diagram, we see that we have a chord that shares a point with a tangent line. Angle x would be half the measure of its intercepted arc, which is 228. So x would equal 114. Now on to part B. We see another tangent line intersecting with a chord at point B, and we're given that the angle is 118 degrees. We know that this angle is half the measure of its intercepted arc, which is what they're calling y. So therefore, we would have to double 118 to get y. So therefore, y equals 236. If two lines intersect a circle, there are 3 places where the lines can intersect. The first place would be on the circle. The second place is inside the circle, and the third place is outside the circle. In the next theorems, we will see what happens when the 2 lines intersect inside the circle and outside the circle. And here are those 2 theorems. The first theorem I call the inside theorem, and the second theorem I call the outside theorem. Let's look at the inside theorem first. So here's theorem 1012, angles inside the circle theorem. If 2 chords intersect inside a circle, so like in this diagram, the 2 chords are intersecting inside the circle, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. So this is a lot of words, but let's just break it down. Angle 1 here would be equal to half of the measure of arc DC added to the measure of arc AB. So for the inside theorem, you add the 2 arcs together. So the measure of angle 2 would be half of the measure of arc AD plus the measure of arc DC. So again, the inside theorem, you add. For the outside theorem, it goes like this. So here's theorem 1013, angles outside the circle theorem. If a tangent and a secant, 2 tangents or 2 secants, intersect outside of the circle. So basically they're just saying if I have a tangent and a secant, 2 tangents or 2 secants, and they're intersecting outside of the circle, then the measure of the angle formed, so we're talking about this angle here, is 1/2 the difference, so this time we're subtracting, of the measures of the intercepted arc. So looking at this first one where we have a tangent and a secant intersecting outside of the circle, this angle, angle 1, is half of BC minus AC. Angle 2 right here, where we have 2 tangent lines intersecting outside of the circle. So angle 2 is equal to half of the arc PQR minus arc PR. And in our third example, this is where we have 2 secant lines intersecting outside of the circle. So angle 3 is half of the measure of arc XY minus arc WZ. So again, for the outside, you subtract. For the inside, you add. So let's look at example number 2. It says find the value of x. So notice that the 2 chords are intersecting inside of the circle. So this is the one where we add. So angle x would be equal to half of the 2 arcs added together. So 63 plus 89. Make sure you follow the order of operations. I would add the 63 to the 89 first and then take half of it. So 63 plus 89 is 152, and half of that is 76. So this angle in here is 76 degrees. You would also know that this angle over here is 76 degrees. And you also know that these 2 angles form a linear pair, so they're supplementary. So you could also find these 2 angles by doing 180 minus 76. So both angles would be 104 degrees. So once you find one of them, you can find all 4. And now on to our last example, number 3. Find the value of x. So notice this time we have a tangent line and a secant line intersecting outside of the circle. So this is where we subtract. So this angle x would be equal to 1/2 of the two arcs subtracted. So you take the bigger arc minus the smaller arc. So 78 minus 42. And again, follow the order of operations. Take 78 minus 42 first, and then take half of it. So 78 minus 42 is 36, and half of 36 is 18. So this angle out here is 18 degrees. That's it for this section. Make sure you jot down anything you don't understand that we can cover in class, and we'll see you then.